Okay, normalization. Um, to discuss about normalization, first thing that comes is like the database and the type of the database. So when you do normalization, the term that comes when you have data on a table. So from the ER diagram, you have created the table, physical table, and then you have all the attributes on the table and with the data. Now, once you have the data on the table, a couple of things you need to consider, especially a table. Now, the purpose of the database is important. Yeah, there are generally two types of database. One is used for transaction, which is like you have frequent insert, update, delete, like banks or any online site, eBay, Amazon. These are all transactional. Frequent insert, update, row by row tables are going on constantly. These are transactional. Report database is something different, or OLAP database is something you need to, the database that is for reporting. You need to run the data on millions of record to get statistical information or reports and other stuff. So so that piece is not considered for normalization basically. Normally if frequent transactions are there are a lot of issues you need to consider, and one of the issues are the insert, update, delete anomaly. Now, what is anomaly? And also there are issues on dependency and inconsistency and redundancy on the table. So let's see the example. So if you see this table has employee table, and let's not think that that we used to see like two tables. Let's consider this is an employee table. It's a one table. We don't have department and employee separately. All information in one place. If you are designing, if you have received a table like that, you need to consider a couple of things. So first thing you can see is department number on employee table. That's what you can see. Now employee number, these are employees, and you have departments. So you can see here a couple of entries are there that belong to 10, 10, 10, and 10. Now if you want to delete record for 7782, 7782, and then 7934 and 7839, if you decide to delete all these three records, what will be happened? You are basically losing department 10 in record information. That record, the department number 10 is accounting. Department number 10 is accounting. So if you delete that record, your information is lost. Which one? Department 10's information will be lost from the table. So this is a delete anomaly. Insertion anomaly is like, okay, you have only department but you don't have employee information. So you can see here on this table, employee number is primary key, and by the definition primary key, it cannot have null value. So so you cannot insert even the data into it. Why? Because you have you have only department number that is 40 you want to insert, and then department is physics on maybe Alabama, Mobile, Alabama, or somewhere else. So entire attribute here will be filled up with null values because you don't have any employee on this department yet. But you cannot insert because in this place you cannot put in a null value because it's a primary key on the table. So this is insertion anomaly. Update anomaly is like you have department 10 and then accounting. Now if you want to change department 10 accounting, okay, you have to change it everywhere that is department 10 and accounting. Now this table is small. When you have billions of record, let's say, so what will you do? And you may have like huge information here that belong to department. Okay, so everybody you have to update it, so it will take more time to update everywhere just for 20 records. And also another thing is redundancy. So you can see here this as department. Now if you consider that we have department phone number, department address, department start date, so many other columns can be here. Now every time you have 20, you are writing research Dallas and then same address, same phone number, and so many other attributes information. Now you may have let's say 50 million records, and for 50 million records there is no use just to write 20 research Dallas same record over and over whenever you have 20. So it's a redundancy, repetition, data repetition. These are the problems that you have on a general table wherever you need insert, update, delete operations. So what is the solution for that? So the solution is normalization. What is normalization? It's a database design technique which organizes tables in a manner that reduces anomaly, redundancy, and inconsistency. Now dependency is what we will learn later on. Dependency is like a functional dependency. We will understand later on. But inconsistency, we saw that even here, if you just update on this place where you have 50 records, everywhere you have to update, otherwise it will be inconsistent data. Research will be updated and elsewhere is not updated. So and if you have to update, it's like extra work for you. So it will take more time to update or insert. Every time you insert, everywhere it's 20, it will update it. It will take more time. So once you design that the table, okay, then by the normalization process, there will be no anomaly, redundancy, or inconsistency. E.F. Codd, he basically proposed initially about this normalization process. He also invented the relational database management system model. Now before we move on to normalization, we need to know certain terms on key. Now key we already studied in transaction T-SQL, transact SQL. Now let's see the definition of key. I would like to put the composite key on the top. Now what is key? Now key is attribute where value is unique. Okay, so we will see that example, like value is unique on a table is social security number. Now obviously on a table you can put social security number multiple times, but let's consider employee. So you need to understand that an employee table, it's an employee entity, as I discussed in ER diagram or employee table. So on employee table, you don't want like the record that is there, it's for each entity. So 7369 is an entity, 7499 is an entity. So each and every records are entity. Okay, this information is only belong to Smith clerk. Smith. 7499 belong to Allen. 7521 belong to Word. Now if we have social security number, it has to have a unique value for that, or driver license number. So these are unique. So in relational database management system, the attribute where value is unique is basically called key. So it has the ability to become a primary key, which will which can uniquely identify a row. In other hand, it shows that this record, first record, is belong to a certain person, okay, or certain entity, or certain like book, you have book ID is there. So this information, first record, will belong to only one specific book on book table. Okay, now it can be a single attribute, key. It can be a set of attributes. So Together you can make something to uniquely identify record that doesn't have any repetition. So let's say employee number, employee date of birth and name cannot be the same. So if you consider that way, it's just a thought, or maybe with the salary, or maybe with the hire date, it cannot be same. So if that is the process, then that can be considered as three attributes together can be a key. Just letting you know, we have key, and then we have candidate key. Now key is like an attribute that or a set of attributes that has ability to uniquely identify a row. Now second definition, if you see on key, that is a super key. And now super key and candidate key, it doesn't super key and key doesn't have any major difference. It's the same thing. Basically it's an attribute or set of attributes that uniquely identifies an entity. Key also called super key. So it's the same. There are not no difference on that. Now candidate key is like it has ability to uniquely identify, but it's minimal. So minimum number of, like for instance, social security number or driver's license number, and additionally another attribute if you add. Now the first one, driver's license itself, can uniquely identify, but if you add additionally with the salary and make it as unique key, so that has also ability to uniquely identify. Or let's say on department table, there is a rule that on a company that on one state we cannot have two departments. Okay, one state, one department. So 50 department, 50 states. Now obviously department name cannot be repeated, and on the other hand state cannot be repeated in this case. So both has the ability to uniquely determine the row, but you can make you can consider, you can make a key or unique key, you can make together department name and location together, you can make a key. So this kind of key is called a candidate key, and the minimal one means like out of this two, if you consider just only one that you will make, which is like a department name, so that is candidate key. And if you consider both of them, that can be considered as like a composite key. And now composite key is like, it cannot be like only with one, it has to have more than one, more than one attribute, two or more. If you use that for unique key to show the uniqueness of the table, so in that case you can consider that as composite key. So just to review, key is any set of a single attribute or set of attributes that has the ability to uniquely identify a table. Super key is same like key. Candidate key is like whoever has the ability, okay, to uniquely identify a table. Now it's the minimal set. Now you again you can have like three attributes together to uniquely identify a table, but out of this three you can also uniquely identify with the two, date of birth or and date of birth and name. Let's say example is date of birth, name and salary together, you can uniquely identify, and you decide three together is your unique key for a table. Now if you reduce that, okay, it can do that, but let's take the lesser amount, and you find out that okay, date of birth and name is sufficient for that. So both two attributes and three attributes has the ability, they have the ability to become candidate key, but the candidate key is the minimal one. So you take the minimal, which is 2, and that can be called as candidate key. Composite key, as I said, like if you use for your key more than one attribute, that is basically called candidate key. And primary key, primary key is the key that is same like a candidate key, but you decide for a table that is primary key. So so the main difference between candidate key and primary key is primary key cannot be null. So that is the main determinant of the table that basically uniquely identify each row. So that is about primary key. So one more time, primary key is a key on a table that uniquely identify each row, but it cannot be null. Candidate key is like it has the ability in that case to become a primary key. You can understand that way. It has the ability to become a primary key, that is candidate key, but it's not the primary key of the table. So whatever you decide that this is the attribute that will uniquely identify each row, okay, that is your primary key. In that table, let's say employee number, that is your primary key. If you have social security number, that is your unique key. Okay, and that can be also called key. That can be also called super key. That can be also called a candidate key. But that cannot be called as composite key. But if on your table, if you decide that job and job and hired, it cannot be same. Okay, so together you will make it as a unique key. So this is also this will also be a key that uniquely identify the rows, but it has the ability to become a primary key. Yes, true, because you are considering by your logic or rules that they cannot be repeated. Now, so that can be called as composite key. Primary key I discussed, and foreign key is on if you bring a primary key from a table and put it as a reference, that is called foreign key. We have seen that in T-SQL, that department number that comes to department employee table as a reference, that is called foreign key. I will show that. So if you see this table here, so this is employee table on the left and this is department table on the right. So and on department table, this is department number is primary key. Okay, and this has been used on employee table as a reference. So this guy, he is belong to department 20, but department 20 doesn't have information details. So where we can get that, the main point is here. So a reference has been used here. So 20 has been used, department number, as a reference. Okay, that's why it's called foreign key. So it's a foreign key is a reference on a table that's basically a primary key of another table. Now normalization has several steps. First of all, we have first normal form, then second normal, third normal, fourth normal, B, C, and F. So we will study for first normal, second normal, third normal, and B, C, and F here. Based on generally all the anomalies and issues are resolved on these 4 steps. Now there are certain circumstances that will require more normalization, but that's generally not you require for regular database. First normal form. What is first normal form? So the last 2 points are more important on that, but these are basic. So table, remember that the table is also called relation, and you heard the term relational database management system. That relation is referred to table. Now relation, this constraint here for 1 and F, that is a attribute of or characteristics of a relation or a table. Okay, row can contain data about an entity. Okay, so I already discussed that the employee table, each record will have information about one entity, that is 7369. 7369 is an entity, and total table is called entity set. Okay, what is next? Column contains data about attribute of entities. So column is basically attribute of entities. We already discussed in ER diagram. So each column is like attribute of employee table. All entries in a column are of the same kind. So as you can see, job types are same, like similar information. You cannot have name on job field, or on name column you cannot have job information here. Okay, next item is each column has unique name. So unique name means salary is a unique name. You cannot have another salary here or another salary here. Or commission, you cannot have another commission. Okay, so same on column heading or column name or attribute name cannot be same. You cannot have employee number, again employee number, and again employee number. Okay, now last two, these are most important. Cell of the table hold a single value. So record will be single valued attribute, single valued. What it means is, if you see this table here, as author we can see two authors on one field. This is one attribute or one column where it's supposed to have only one information of one author, but it has two authors information, so it's violation of first normal form. Next thing is no two rows may be identical. So you cannot have the repeated rows. Like for example, this table, you have first record belong to first row belong to whom? 7369. All the records belong to him. Now you cannot have another 7369 okay, that carries the same information. Okay, so two row cannot be identical. So we will see how we can resolve this issue of first normal form. So this table that you can see here, it's violation of first normal form. We will see in details, but one of the key that we discussed, it's like you have two records in one field, two authors in one cell. So how you can resolve that? In transaction SQL you saw string operations there. To remove that, you have to write a query to resolve this. Okay, so it's a string operation. You identify the comma, and then from there you select substring from there, and then after column you select substring, and then that you insert on different table. You will make a table and you will insert there. Okay, and the next thing that is there is repeated rows. So we will see that problem. So on this table you are seeing 23 records. Now with your own eyes you cannot see, okay, it has repeated rows or not. So how will you do that? That is important. How will you find from a table that it has repeated rows? One employee record came 2 times. Okay, we will check that. So here you can see like 21 records. What we have done is like select distinct star from this table. So all the record will be distinct. Okay, so distinct record, all the attributes distinct. Okay, select distinct star from this table. So no repeated, if there are any repeated rows, that will be eliminated. Now how many you can see? 21. So earlier we saw normally it comes like 23 with the query count query for general table, and then if you do distinct, it's coming 21. So it has difference of 2 records. Now where are those 2 records? How will you identify that? So if you put there on a table all the attributes there and put count star, and then group by all the attributes, and then if something has like more than one attribute, it will come here. Now we have so it's supposed to have only one count. Okay, the way I'm saying for this table, employee table, if you consider so if you group by entire record, okay, so this record count is how many? Only 1. This record count is how many if you do group? But if you have more records, same records like this came 2 times, So if you do group by, then count will be how many? 1, 2. It will be 2 count. So it's like that. Okay. So how will you resolve this? Like so you can create additional table, and you can use group by or select distinct query as well, that we have discussed here. One second. Yeah, on this slide, slide number 9, you can see here, if you see distinct star, then it will just show, and with this record you will insert this record into another table, and the process will be like this: insert into table name, and then you put select statement there, or this way group by you can use and just insert that. So the repeated rows will be eliminated. If you bring the data into, if you write that query of substring function, string operation, then it will look like that: author 1, author 2, author 3. So it's not in one field has only one. Okay, then author doesn't have, it has null value in it. Now this is completion of first normal form, second normal form, and third normal form, as well as B, C, and F. To understand that we need to understand functional dependency, transitive dependency, partial dependency, prime attribute, and non-prime attribute. So we will start with the functional dependency. What is that? So functional dependency is this, that whenever you have a record, okay, it can be employee. Let's consider just a department table. So department table, accounting, and New York, and research, Dallas. Okay, these two will not appear in department table. But let's consider like employee and department are together. Then it has repetition, and even if it has repetition, whenever we will see accounting, New York will come, and again your accounting and the New York will come. Okay, that is called functionally dependent. Whenever and this is functionally dependent on accounting. So location is dependent functionally on department name. So whenever you have accounting department will be located in New York. Accounting cannot be located in New Jersey or somewhere else. Whenever you have research, Dallas will be there. Research, and then Dallas will be there. So this is called functional dependency. Now whenever you have, so here you can see, we will see this part. So let's consider A as department name and B as location. So A is called determinant and B is called dependent. So we will need that term here. Another example, you can see this table, just attributes are there. So social security number. So employee name is dependent on social security number. Okay, and then department date is dependent on social security number. Address dependent on social security number, and then department number, that is also dependent on social security number. But department name is not dependent on social security number. What is it dependent on? This is dependent on department number, and the department, so manager SSN or something, that is dependent also on department number. Okay, so that is functional dependency. Here you can see on employee table, we will be able to know functional dependency here, everything together in department table. So whenever you have research on this table, whenever you have 20, you have research. Whenever you have 20, you have research. Whenever you 20, so department 20 always come with the research department name. It will not have a different name. Okay, or wherever you have department 20, Dallas will be coming. So both this attribute are dependent on this 20 number. Okay, that is called functional dependency. And in this part, remaining part, everybody here on the table is dependent on this guy, this employee number. It's like Smith belong to whom? Belong to this number. Clark job belong to whom? Belong to 79. Manager this belong to whom? This is the one. And hired it. What this record belong to? This. Salary belong to this. Okay, and then commission belong to this guy, and then department number belong to this guy, but research belong to this, Dallas belong to this. Okay, functional dependency. You can see here, as I discussed earlier, there is functional dependency. Now let's consider this way, that you have research. You can just check with this one as well. Whenever you have Dallas, you have research. Okay, and let's not consider the department is there. Just forget about it for now. The department number is there. So because this is a surrogate key. Now what is surrogate key? I think this has to be mentioned. So this is employee table. So employee information basically not a part of your requirements. It was not there. So whenever you have requirements, you have employee name and job and manager, whoever is manager, the name will be there. Okay, or hire date. Okay. So this guy belong to manager of. This guy is manager of this person, which is here, which is Ford. So Smith is manager of Ford. So information will come like that. But you put here employee number as primary key. This is surrogate key. You add an additional attribute to uniquely identify the rows. Now why is that? Because when you do a search of any record, it will be very easy to pull up. Like for example, you have primary key on 3 attributes. Then whenever you are searching that person, you have to put here like 3 attributes, where employee name is Smith and job is Clark, and then manager is 7902. But if you know this is the attribute belong to Smith, you will put on your search like where clause that where employee number is 7369. So it will be easier for you to pull that information up from that table. So that's called surrogate key. So employee number is a primary key, but it's also called surrogate key of the table. The reason why? Because you added this attribute and made it like unique. Okay, and it cannot be null. So that's why it's primary key. And since it was not there in the requirements and you added it by yourself to uniquely identify record, this is called surrogate key. Okay, now let's go back. So now for this table, let's as I said, let's not consider the department number is there. So it's a surrogate key, obviously. Initially it was their research name and Dallas. Okay, so now if you want to check here, like Dallas is dependent on research, which implies research department is located in Dallas. So obviously whenever you have research department name, the Dallas will come, obviously. Now how will you see? So this is determinant and this is dependent. We will see how we can check that. So this is determinant. Okay, both way we can check. Here it should be same, but you can just check that way. You put it there, department name. Okay, and then whenever you have Chicago, it comes group count comes 1. So what we are doing is, on that query, you are grouping all the location. Okay, grouping all the locations. So Dallas will come, and then you are checking group count of this research, how many, and you are doing distinct. Okay, so this way you will have only one group count. So that implies it's functionally dependent. Whenever you have Dallas, the research will come. Again, one more time, just to explain you. So in this query, what we are doing, we are checking wherever is Dallas, whether it comes research or not, but or other way around you can check. So we are grouping Dallas. So group by Dallas. So if you do a group by on Dallas, okay, so only Dallas, Chicago, and New York will come, and then you are checking how many counts of department name comes. So research will come like how many times. So Dallas count will be like 3. But if you put here distinct, okay, which is like I don't want to see like repeated ones, just unique one, not repeated one. So research will come for Dallas 3 times, but if you put distinct, then only 1 time it will appear, and that's what you want to see. But if you would have like research here and then something else here, then for Dallas you would see 2 counts. If you'd see Dallas research, Dallas physics, Dallas chemistry, then even after this you would see group count would be 3. So if you see group count is 1 with the query like this, then that implies the functional dependency exists. Remaining topic: transitive dependency, partial dependency. These are these two are dependent, are similar to functional dependency, but we will see like what are the definition of transitive dependency and partial dependency when we discuss about second normal form and third normal form. Prime attribute, non-prime attribute, we will also see during that time. So let's move on. So second normal form. So whenever you have so first of all, on a table you need to find a candidate key. So what are the attributes that has ability to become primary key? Okay, let's say social security, it has ability to become a primary key because it doesn't get repeated. Though you will be using employee number as primary key, that's not a thing, because we are not going to use social security in our table as primary key. Now you will see sometimes like people are using like that, it's up to them, but I'm talking about general process and what the book discussed, the book of database system processing by Cronky. So instead of using social security, instead of using like information as primary key, he used surrogate key. So, and he preferred that way. So it's also standard. You will see many places that this is the standard. But other people they have used social security, not social security, like similar driver's license number, or maybe not driver's license number, some other important number as primary key. So that will be there, but it's not I think optimized way to select a primary key. Now candidate key, the ability, the attribute, the key or key set of keys that has ability to become a primary key is called candidate key. Now how will you identify the candidate key on a table? So you do the group by. Okay, let's say you want to see whether it has ability to become candidate key. Now employee number you group by, so if any name is there, so group count will be more than 1. Okay, you obviously want to know, like for example, on employee table you're looking for Abu, so Abu comes 1 time, so you do group by and see the count of Abu, and the count will come only 1 time. Okay, if count comes to more than 2, then it implies it cannot be a candidate key, or it doesn't have ability to become a candidate key. It's not a candidate key. So that is first preference of so whenever we identify second normal form, we will identify the candidate key, and then we have to check if there are any partial dependency or not. Okay, so we will see what is partial dependency in next picture, and we'll come back to this slide. So partial dependency, if you see this picture, you will understand what is partial dependency. Now in this picture, let's forget about this bottom row. So these two are together candidate key, you can consider. Okay, or together you can say it's a primary key together, or candidate key. Now let's say this is another attribute, but these are dependent, functionally dependent on, C is functionally dependent on A and B together. okay, and D is also functionally dependent on A and B. What it means, we already discussed about functional dependency. By now you should be understanding, but we can see on this picture as well. So A and B, okay, it will come like when A and B will not be repeated on the table. So A1 B1, A1 B2, A2 B1, A2 B2, okay, and then A3 B3, like that. But these are not repeated. And but whenever you see A1 B1, okay, it will come only one times, okay, or if it appears on the table again A1 B1, you will see C1 there. Now you are not seeing whenever A1 B1, only C1 is there, okay, and A1 B2, C1 will never come here unless the same attribute comes that way. Now one more thing, just want to clarify here, that is understand the determinant and dependent, okay. These are dependent on this two. So what it means is like, let's go back to the previous picture. So whenever you have birthday, social security number is there. So birthday can belong to other social security number, that's true, but for example 1 2 3 social security number, okay, then there will be specific birthday, and if he appears again, okay, then the same birthday has to come. Now same birthday can belong to other social security number as well, it's possible, but what I'm trying to say that if 1 2 3 comes, okay, and date of birth is 10/10/2012, again if 10 comes, social security number, same birthday will appear. So that is called functional dependency. So C1, you can see C1 is here, but that's not the main problem. Main characteristics of functional dependency, whenever you see A1 and B1, okay, you are seeing C1. If again A1 B1 appears, C1 has to be there. Now you cannot see A1 B1 again on the table, so you can check. So this is functionally functional dependency exists on this table, okay. This one as well for D1, you can check that whenever you have A1 B1 D1 and A1 B1 is not repeated, so they are functionally dependent. That's what functional dependency means. Now you can see another functional dependency, okay. B is dependent on D. So D, whenever D is there, C1 D1 you can see, again C1 D1, okay, C2 D2, again you can see C2 and D1, I'm sorry, it's a B and D, it's not so B determines D. So whenever you see B1, D1 comes, okay, and then whenever you have again B1, D1 comes. So B2, wherever you see B2, D2 comes, and then again whenever you see B2, D2 comes, okay. So that's the way you can see the functional dependency exist. Now this is a table, conceptual table with the data to represent the issue on second normal form violation. So this table doesn't have second normal form. What it means is like these two can define these two attributes, but there can be no personal dependency, which is like these two are called prime attribute, okay. These two are part of primary key or your candidate key, okay. These two are called prime attribute. These two are called non-prime attribute, okay. These are determinant. These two are dependent. So these are non-prime attribute, these are prime attribute. So it says that a non-prime attribute cannot depend on part of prime attribute. That is the violation of second normal form. You have to fix this. And why the issue is there? Why? You will say like, okay, what is the issue on the table? So you can see here, so this is the table. Now three things we will check, okay. Insert, update, delete anomaly we will check. Repetition, obviously repetition will be there. because you saw previously the example of that. Now anomalies, you want to insert B4 and D3 because it's dependent. We saw on employee department table, you want to just insert you have information about department, and you saw department name and location has dependency. Okay, and you have a department table, information just came belong to department, which is new department came, but it doesn't have any employee. You want to preserve that information. Now here if you want to insert, because it has functional dependency there, let's consider a department. So here you have B4 D3, but you don't have information here. You want to insert here. It's a primary key, it's a product of primary key. You cannot be null. Okay, it cannot be null, so you cannot keep it empty or null here. So that is insertion anomaly. Now delete anomaly is another one. Delete, you want to delete from this table A3, deletion of entire record, that is here A3 B3 and C2 D1. Okay, entire row you want to delete. So what will be happen for that if you want to delete entire record? So if you want to delete entire record, you will lose some information. So as you can see that B3 D1, it's not there anywhere else. Okay, and this determines this, which means like the information, if you delete the entire record, so D1 and B3, this information will be lost. You are just removing this record. You don't want to have this record, but this one has dependency on B3. Like for example, you can think that way, that department location and department name here. Okay, so if that is the case, if you delete this record, so your information will be lost. So that is the deletion anomaly. And then you have update anomaly, that is there. The way it works is like you want to update B1 and D1 to B1 D1 you have here, and you want to update that to B1 D4. So this is not the one place. Wherever you see that, you have to update everywhere. So it's a small table. If you have big table, everywhere you update. So that is the problem here. Now how will you resolve this? All the anomalies and repetition is also there. You can see whenever you have B2. Now how do you fix second normal form violation? So as I said, it has a partial dependency, so that's why we have anomalies and other problems. So how we can resolve this table? So we have this table, so we have to remove the partial dependency, like D is dependent on B. We have to remove that kind of dependency. What we should do for that? So solution is, you have okay, this example is like more with the anomalies. Okay, so let's move on. So here is the solution. So solution will be like we have two tables from one table. So these two tables, we have to create from there two tables. One with the first functional dependency on AB. C has dependency on AB, so that will be split. Now you know B and D has dependency, so we will take that out. Okay, and we'll create another one. So that will be the solution. In that we will not see any dependency in it. And so let's see how it goes in the solution. So if we split the table, it will look like this: A, B, C and B, D. Okay, so all the information will be intact. Now only thing that will be there is we have to check whether the anomalies are gone or not. Okay, so insert anomaly, on this record you want to insert B4 D3. Okay, here that you can comfortably do that, B4 D3 here. And for that, like this is basically you can consider as department table. So if department information you have independently, it will go there, and then there will be no issues on this table. So we don't need information belong to A and B attribute or A and C attribute, so it can go by itself, before D3. And then in deletion row, so if you want to delete the record and you want to delete record A3 B3, okay, deletion of this record, there should not be any issues because C is dependent on this two. If you delete that record, that's fine, but the problem is B4 D3, that relationship will have no impact because you are not touching that at all. And update, if you want to do update, you don't need to update everywhere. B1 to B1 D1 to B1 D4. So B1 D1 to, you will change that to B1 D4. So if you want to change this, only one place you need to change. Okay, so that is the solution for that. So table will look like this. So this is one more example for second normal form. It's just a kind of a real life data scenario. So you have subject table. Here you can imagine a subject table, primary key is subject ID. We have got there, and then semester ID, okay, is this, and then what? Who is the advisor? Okay, so this subject has been offered for this semester, okay, and this subject has been offered for this semester, and these are the advisor. Okay, now this subject can come again, but we will not see, because these two together are primary key. So this this row will not be repeated. Okay, but 2 can come with 2007 fall 2007, 2 can come with spring 2008. But one thing you can see that there are additional dependency, that is whenever you have fall 2017, this advisor come. There are only one advisor for one semester. So this one, then this one. So it has functionally, so advisor is functionally dependent on semester ID. So this two together is primary key for this table, but you can consider that it has ability to, like a candidate key, you can say, mention about candidate key, and then this one is dependent on this one. Okay, this one is dependent on this one, advisor is dependent on that. So that is called partial dependency. So advisor is a non-prime attribute, is dependent on part of prime attribute. That is not allowed. So we have to split that. How will you split that? You will have this table by itself, this attribute by itself. So this attribute will come, and then you will have semester ID separate table, and advisor will go there. So since advisor has dependency on semester ID. Third normal form. Third normal form is basically transitive dependency. Okay. So what is transitive dependency? So if you see this picture, it will show you about transitive dependency. So you have A attribute, that is the primary key, or you can say candidate key, and it's the prime attribute, and then these two are non-prime attribute. So B and C are dependent on A. Okay, B and C are dependent on A, but you can see here C is dependent on B, and these two are not part of prime attribute, which is this one, like is a prime attribute, which are part of the primary key or candidate key, you can say. But this B is not a part of prime attribute. C is also not prime attribute. So this is called transitive dependency. So if non-prime attribute is dependent on each other, okay, or any of the non-prime attribute is dependent on other one, that is called transitive dependency. So this is not a part of candidate key, this is not part of candidate key or primary key, but these two are non-prime attribute, so one is dependent on another one. So if that is the case, it's called transitive dependency. So if we have transitive dependency, we will have all the anomaly issue. And I discussed in my previous lecture about second NF, so you can try this way and imagine on the table it's the same way. You will see that when you have update, that there will be anomaly issue, insertion anomaly issue. All the examples are here with the notes. Now how will you split that table? So if you have transitive dependency, okay, then the way it will be done is you will have this table A and B together, and B and C will be separated out, because you can see here, and we will also see the example. So B is dependent here on A, okay, so that is there, so it's fine. But another dependency BC will be separated out because C has dependency on B, so it will be a separate table, okay. So with that we can get all the information, because B is dependent on A, C is dependent on A. With that, this two table, we can get information, anything related to C and A, by joining the table. So let's see how we split the table and normalize it. So our table was like this in the beginning, 3NF, okay, and now if we split that, it will look like this. So initial phase, and then we have A and B, and then B and C. Now we can check if the anomalies are there. We can try that out. So how will you try this? So you will try to insert record directly on this two, and then you will check all the anomalies if they exist, like that. Now you want to insert B4C3 and you want to delete record, and you will see like if there are any anomalies there. So after this split from this table, you do insert, update and delete, and check that if the anomaly is still there. Okay, now BCNF main thing is super key. So here you can see one example. Okay, so these two are prime attribute, these two are non-prime attribute. Okay, and then first normal form, second normal form, you saw partial dependency. It's not here. Partial dependency. Partial dependency is like the non-prime. We can see it from this picture. So non-prime attribute is dependent on part of prime attribute. Okay, that was partial dependency, which violated the second normal form. Now, what is in BCNF? Here B itself is a prime attribute, okay, and this is dependent on a non-prime attribute. So that is not a third normal form issue, that is not second normal form issue, because if you see the constraint of second normal form, that is covered. The third normal form, you can check it out, that is also covered. But here this is there are no issues on it, but additional issue is this, that not this one is dependent on B. Prime attribute, part of prime attribute is dependent on basically you can say an attribute is depending on non-prime attribute, okay, which means it's not a candidate key or something. It has to be a candidate key, or that is called a super key. You can say candidate key or super key. It has to be a super key. Anything that depends, okay, on other one has to be super key. So this is dependent, okay, dependent, and this is determinant. So determinant has to be a super key. So if not, that is not the case, so BCNF will be violated and we will see the anomaly issue. And the anomaly issues are here. If you want to insert some data for, now as you can see, D determines B. So if you want to in B and D, if you want to insert that data, same issue will be happened. You have to add null value on this too, so which is not allowed. You don't have A information yet, so that will be one issue. And then deletion record, if you want to delete a record, you will see anomaly, the A3B1. Out of this record A3B1, if you want to delete, but you know that this one D is determines B. Okay, so this information will be lost. Okay, there are dependency there. If you delete this record, so here if you consider this like department information again, so that information will be lost. These two are different information, these two are different. So you need in future these two information. If you delete this record, you have dependency, which means very important information that will be deleted. Okay, and update anomaly is same like whatever we discussed, D1 B1 to D1 B2. So it has functional dependency, B1 D1, B1 D1. And if you want to make a change on that to D1 B2 D2, then anywhere you have that record, you have to change that as well, or otherwise it will be inconsistent information. So how will you resolve this? So this is a deletion anomaly example. What will be the issue for if you delete that? What information you will lost? You will be lost from here. And then this is update anomaly. You can see here where is the issue. This is also update anomaly. Now so how we will normalize the BCNF? So the dependency, as you can see, D to B, so that will be splitted, and then A, B to C will remain as is. So D has dependency, that will be separated out. Let's see the data example. This is the data example. Now you can try by yourself, like following the same insertion, update and delete anomaly, and check the issue. Okay, so I have provided here another example. Okay, it's a real life data representation, and same, it has been mapped with the column A B C D. Now you have data here. Okay, now you can do insert update to check the anomalies and issues, and then this is how you split the table. So it will be split into two. So this one is like initial 4 attributes. After you resolve that, you resolve this way, and you can check the anomalies before and after. Okay, and this is the solution. This is what it will look like. So that's all we have for normalization. Now denormalization. So what is denormalization? So normalization we studied like that whenever you have basically insert of the delete statement, frequent delete statement, for that it's better to have normalized table, so there will be no insert of the delete anomalies, redundancy, and inconsistency. But that is like called online transactional database, OLTP. But if it's for reporting, which is OLAP, okay, so for that, like OLAP database, normally these are batch based insertion, like bulk load, but mainly it's used for reporting, okay, and research analysis type data selection. So for that, like it deals with a large table. So if you have large table there and you have splitted up the tables, then join has some cost. Okay, so you need to consider that. Since no insert update delete is there. So just select. Now is the main thing that you need to consider. And selecting from a large table join an independent table without considering the insert update delete part, it's better to have unnormalized a table. Don't split it up, so it will be less cost. It will have less cost because you are not joining table. Joining has cost. So if it's only select, it's better not to join, not to split up and use join query, join in query. So on the right hand side you are seeing normalized table, and if it's not normalized, which is like normal, it's called denormalized. Okay, so if it's normalized table already, and if it will be used for reporting, what will you do? You will just reverse the process back, okay, and make it denormalized like this. So it's just conceptual thing that you have idea of how to do denormalize, or what is the concept of denormalization. Thank you.